Hello, my name is Apostol Vassiley. I'm a research scientist and a team leader at the National Institute of Standards and Technology. Today, I will be talking about bridging the ethical gap in AI, and more specifically, the role bias and fairness play in it. I am unable to join the event in person, but thank the organizers for providing the opportunity to play a video of my presentation. I hope this format will still be adequate for catching your attention and getting the main messages across, and I would be happy to hear from you if you have any questions or comments. My contact information is provided on the last slide. Before I begin, let me thank also my collaborators. This presentation is based on a joint work on the NIST Special Publication 1270 with my NIST colleagues Riva Schwartz, Kristen Green, and Lori Perrin, and my external collaborators Andrew Burt and Patrick Hall from B&H. SP 1270 was a result of an extensive literature review, conversations with experts, a workshop on AI bias, and public comments on the draft version. SP 1270 is connected also to the AI Risk Management Framework and its Resource Center. Mitigating bias is defined as a socio-technical characteristic within the AI RMF. I'll start with the assertion that the bridge over the ethical gap in AI hangs on the fundamental questions about AI bias and fairness. The AI RMF focuses on the fact that risks from AI are real and they cause real-world harms. Bias is one of those risks, and as you can see in this taxonomy, there is more to bias than just data and algorithms. Bias is certainly in the data and the models used in AI, but these computational concepts need to be considered in context and the reality of how AI systems are built within and connect to society. AI systems are also a function of our assumptions, design decisions, institutional practices, and norms. So if we tackle the problem at the level of the data only, we will miss on these important aspects. To really address this, we have to transform the way we think about and approach AI bias. The computational, statistical biases, shown here in pink, occur within the data and the model, and point to systematic errors such as non-representative samples within the population, underrepresentation of groups within the population, over and underfitting the test data, or from how we treat the outliers. For example, content production bias occurs when a model renders a lending or service allocation decision based on a given individual's language use in one context and assigns the person to a group with a lower desirability rank, for example, lower income bracket. The next category is human bias, shown in green. These biases relate to how individuals or groups perceive or fill in missing or unknown information. They are prevalent in the decision-making processes across the AI lifecycle and in the use of AI once it is deployed. Automation complacency, sometimes called system overtrust, is a good example here. This happens when an end user or practitioner over-relies on model output because it is AI-based and thinks the results are more accurate or objective than they really are. This is particularly problematic when the model output is biased on its own. Moving to systemic bias, shown in purple. You can think of this one as cognitive bias at an organizational level or the implicit and pervasive drivers for how institutions make decisions. Systemic bias is prevalent in the data, the models, and the organizational assumptions, practices, and norms where AI is produced. An example here is how AI organizations want to get their product to market quickly. To be sure, this by itself isn't a bad thing. But if individual incentives If institutional incentives, lead to technology being released that conflicts with societal values and in turn produce harmful outcomes, it may also result in non-compliance with legal standards, then it is a problem. The main takeaway here is there is more to AI bias than just data and algorithms. A side note here, the concerns about potential harms are not purely academic. If you are paying attention to the drip of AI incidents in the news, you will see there's a lot of coverage and maybe even some hype. I'm going to stick to just one example here in the interest of saving time. AI-based hiring sees its fair share of real-world incidents. But one specific issue that the EEOC, or the Equal Employment Opportunity Commission, has recently released guidance on is how such apps can inadvertently screen out individuals with disabilities, since they may be more likely to perform poorly on the types of assessments used by the screening app. These assessments are in effect designed for a population that excludes those with disabilities, a violation of federal law and exposing companies to liability. The fact that this is discriminatory seems really obvious now, but this type of technology has been in place for years and used by many companies all over the world. This also illustrates how the speed and scale of AI bias is far more damaging than human bias alone. So what's missing? Well, we aren't paying enough attention to the other categories of bias. On the left side of this slide, the picture illustrates how the current focus is almost exclusively on computational statistical biases. But human cognitive and systemic biases are prevalent across AI. They tend to be difficult, some might say impossible, to observe and measure. Due to the lack of focus on these categories of bias, measurement approaches are often poorly constructed or invalidated. On the right side, the AI lifecycle is shown. AI is developed within a lifecycle that is primarily focused on getting technology to market. The typical lifecycle is not, at least right now, set up to identify, assess, and prevent harms. Researchers in Trustworthy and Responsible AI suggest that we need to transform the culture of how technology comes to market. We can do this through what is known as a socio-technical systems approach. The term socio-technical just means that we are taking into consideration the larger social system in which AI operates, its purpose and potential impacts. We can do this with a few strategies: broadening our perspectives beyond the more traditional computational view, and to help us improve processes for identifying limitations and potential negative impacts, adhering to and maintaining scientific integrity, recognizing, acknowledging, and documenting the limitations in the data, model, system, and procedures, and how our assumptions may be contributing to those limitations. All this should sit on strong governance practices and organizational buy-in, which can help combat issues with systemic bias and help change norms from exclusive focus on optimization to a consideration of societal impact and values. Let us now look at the challenges for datasets. One of the very first questions developers need to ask themselves is, do datasets exist that are fit or suitable for the purpose of the various applications, domains, and tasks for which the AI system is being developed and deployed? Not just those datasets that are readily available to us, but those that are suitable for the purpose of what we're trying to do. You have to remember that computational abstraction alone cannot adequately capture the information or dynamics related to the contextuality of the data, cannot account for limitations of heterogeneous, multimodal, sparse, and missing data. So we need to adopt a socio-technical framing and experimental design principles so that we can capture appropriately the contextuality of fairness metrics and the biasing, the adequacy and construct validity of the measurement models, and the constraints for generalizing the use and interpretation of the model. All along, we need to be aware of the human and AI interactions that are relevant at each stage of the AI lifecycle. Statistical methods are extremely important for mitigating representation issues at the dataset level. Bias detection and mitigation approaches such as class or label imbalance measures should be tackled with statistical methods. We should also remember to not train our model on benchmark dataset and then use it on real data in specific applications, especially in cases where the real data has distributions that are vastly different from those of the benchmark datasets. Of course, documentation and communication of the limits of the applicability of the AI outputs is also very important and needs to go hand in hand with the model. Currently, the industry is moving towards adopting data cards for datasets, and this is a step in the right direction. But more work is needed to make them useful for bias identification and mitigation. Processes to account for the socio-technical context in which the application is being deployed are also important. Socio-technical analysis at the design stage to provide the insights into social variations in the dynamics or characteristics of a given phenomenon to better frame the questions for analysis and enable assessments of dataset fit. This should also allow us to identify off-label uses and set guardrails against deploying the model in such off-label applications. We should also adopt processes that involve stakeholders and examine the cultural dynamics and norms and assess impacts. Next, let's turn to the challenges about test, evaluation, validation, and verification of AI bias, or how do we know what's right? Generally, AI bias identification and mitigation at the algorithm level goes in three stages: pre-processing, in-processing, and post-processing. In the pre-processing stage, the focus is on the data and all mechanisms and tools available for detecting statistical bias and generally reconciling errors in the data. This is a very important step in identifying and remedying bias, and if the organization has access to the training data, it is important to look into it. This stage is where you get the most return for your efforts to mitigate bias. In the in-processing stage, the focus is on the model runtime behavior and fine-tuning the algorithm logic or the hyperparameters to minimize the bias during training. This is another important stage to look into if the organization has access to the model itself. In the post-processing stage, the focus is on detecting the bias of a pre-trained model and designing mitigations that compensate for it to the extent possible. This is the most limited opportunity to address algorithmic bias available to organizations that have only black box access to models. In practical terms, this situation is becoming much more widely spread with the advent of large language models. Only a few organizations have the enormous computational resources and data needed to develop and train these models. These models offer some remarkable capabilities, but come also with a lot of epistemic and aleatoric uncertainties and a heavy baggage of bias and fairness concerns. These models are now applied in many use cases beyond the classic NLP tasks, but the deploying organizations have very limited ways in which to mitigate these biases and the discriminatory effects of their use. The related fairness matrix and related practices at the algorithm bring another set of concerns when it comes to testing, evaluation, validation, and verification. Fairness is dynamic, social in nature, and strongly dependent on a specific context or application, and that is why it is hard to distill it down to a universal mathematical definition and reduce it to a computational problem. There are many categories of fairness matrices, and that's why it is difficult to decide which metric to use for a specific application. In fact, the research community still considers this to be an open research problem, how to decide which metrics to use for what application. Of course, fairness is related to legal matters, and therefore whatever definition is chosen for the specific application, it must be aligned with the legal standards for that area. For more information on test, evaluation, validation, and verification, and next steps that NIST is going to take to help the community with this important problem, I suggest you check the video for panel 11 from the second AI RMF workshop. There I hosted a panel with leading experts in this domain, and they provided a wealth of good advice on this topic. The link is in this slide, so please check it when you have time. Next, let's look at human factor challenges in AI bias. There's so many human factor challenges in AI bias, and we could spend an entire presentation just on that. But of course, we only have limited time, so I'll highlight a few considerations here. First, systems are often built and tested detached from context and under idealized scenarios, often with non-representative users. Overly optimistic and also unrealistic expectations for human oversight is a catch-all for flawed AI system decisions throughout the AI lifecycle. There's challenges with untested and non-validated human-in-the-loop configurations. People think that just stick a human there and they'll be able to compensate for all of the AI shortcomings, not considering that humans themselves come with a whole host of cognitive biases that happen to interact with the model bias, and it's only a mystery as to whether these two biased systems attenuate each other or amplify each other's biases. And of course, there's issues with presenting information to end users. What does the information presentation look like? Is it interactive? Have you tested to be sure that the users are interpreting the information in the way it is intended? Design and development of systems detached from user intentions, representative stakeholders, or societal values. So these are some of the high issues that I'd like to mention given the limited time we have. Here I'd like to highlight a couple of misconceptions and limitations. AI systems are used because they can make sense of information more quickly and more consistently than humans. But consistency is no substitute for fairness. Everybody knows that. Yet this misconception has led to the perception that AI systems are more fair and less biased than human decision making. And these perspectives have led to the deployment of AI systems within trusted institutions and high-stakes settings such as hiring or criminal justices, leading to really questionable outcomes. The reality check here is that AI systems can incorporate negative biases and perpetuate harms more quickly, extensively, and systematically than human and societal biases on their own. And we have to keep in mind the McNamara fallacy, which says that just because a decision is based on numbers, that doesn't make it more accurate or trustworthy. So we have to keep that in mind when we are faced with AI decisions and be critical about examining them, not just accepting them blindly. So how can we avoid these sorts of negative impacts of biased AI? Unfortunately, there is no silver bullet, there's no single approach that can cover it all. I'm going to list just a few tools in the toolbox and suggest you check Special Publication 1270 for more information about them. The first tool is impact assessments. They enable organizations to interactively frame risks while accounting for specifics of each use case and generate documentation of any mitigation activities of potential harmful outcomes. The next tool is multi-stakeholder engagement. The main goal here is to fight groupthink, to broaden the perspectives about the system context, to provide more thorough evaluation of the societal impact of the technology, and to leverage, of course, a variety of subject matter expertise, and to engage early and often with potentially impacted communities. The next tool is diversity, equity, and inclusion. And naturally here, the goal is to increase the diversity in AI professions, to empower a diverse group of individuals with a wide range of backgrounds, perspectives, and expertise, which in turn will help to broaden the views of AI system designers and engineers. The next tool is practice improvements. Here, the goal is to enumerate institutional assumptions when developing algorithmic decision systems and map them to the expectations of the impacted community. Another goal is to create a culture of risk, and with the understanding that you can never eliminate risk completely, you can only find ways to mitigate it. And to foster an environment where AI practitioners can actively challenge and question the steps in modeling and engineering in order to help to root out the statistical biases and the biases inherent in human decision making. And the final tools is the system and procedural transparency. And the goal here is to design approaches that take end user perceptual differences into consideration to enhance interpretability and avoid misinterpretation of output. Well, next, let's look into the governance of AI bias, or how do we manage and provide oversight. Governance should be a holistic implementation tier, as I mentioned earlier in my presentation. It's the underpinning for everything within the AI lifecycle. Its governance should be socio-technical in nature and should inform each phase of the bias management throughout the AI lifecycle. Governance should also focus beyond the technical artifacts such as the AI system alone. It should cover organizational processes and include cultural competencies. Here I'm going to discuss important aspects of governance. This is a large topic, and it could be just a separate presentation on its own, just for governance. I don't have the time here, and probably won't do justice to it by covering at a very high level just a few aspects of it. But I encourage everyone to check Special Publication 1270 again for further information about them. Governance should include monitoring, which is critical for knowing the real performance of the deployed system. This is how you detect harmful outcomes and take measures to rectify them. Governance include recourse channels, and that is to enable feedback channels that allow system end users to flag incorrect or potentially harmful results and seek recourse for errors or harms. Governance include policies and procedures. The goal here is to develop written policies and procedures that address the key roles, responsibility, and processes at all stages of the AI model lifecycle. Another aspect of governance is documentation. Documentation helps to systematically implement policies and procedures and supports accountability. Accountability is the next important aspect of governance. Governance without accountability is ineffective. Everyone knows. Governance covers also culture and practice. For the AI governance to be effective, it needs to be embedded throughout the culture of the organization. Mature governance covers risk mitigation, risk tiering, and incentive structures. It comes with the acknowledgement that risk mitigation, rather than risk avoidance, is the effective factor in managing such risks. It allows or enables organizations to triage the risk and prioritize their mitigation accordingly, and aims at aligning the pay and promotion incentives in the organization to ensure that everyone is truly motivated to use sound development approaches, to test rigorously and audit thoroughly. And governance also covers information sharing. The goal here is to share information about incidents or other harmful impacts from AI that helps to elevate the importance of AI risks and provides information for teams to avoid past failed designs or practices. Okay, so let me conclude my presentation with these next steps. We're currently working on importing the bias guidance into the NIST risk management framework document. The idea here is to take parts of Special Pub 1270 and incorporate it into the risk management framework in order to make it easier for the community to access and understand. We're going to continue to explore further the test and evaluation of bias in context, and NIST is currently working on setting up a project to collaborate with the industry and academia on establishing best practices for managing bias in context, one context at a time. And if you are interested to get more information about it or even to join us in this endeavor, please contact me. We're going to fund a research about human-in-the-loop practices and reliance on human oversight. Stay tuned for more details if you're interested. And finally, we're going to feed the experience, the best practices and knowledge from research into standards so that we can develop effective standards that benefit us all. Here is my contact information. Again, I regret missing to attend the event in person, but hope that the recording of my presentation interested you. I would love to engage with you and invite you to send me your questions and comments at the email address shown here. Thank you.